Hello Ace, this is RetroTK2 and today we're learning about delegates in C#. If this is your first C# series, I'd strongly suggest watching the series from the start. Card should be on your screen now. And if you haven't already, might I suggest downloading the channel files and accompanying this video. Card should be on your screen once again. So let's get started. What is a delegate? Well, according to the Microsoft docs, a delegate is a type that represents references to methods with a particular parameter list and return type. When you instantiate a delegate, you can associate its instance with any method with a compiled signature and return type. You can invoke or call the method through the delegate instance. Delegates are used to pass methods as arguments to other methods. Event handlers are nothing more than methods that are invoked through delegates. You create a custom method and a class such as a Windows control can call your method when a certain event occurs. Any method from any accessible class or struct that matches the delegate type can be assigned to the delegate. The method can be either static or an instance method. This makes it possible to programmatically change method calls and also plug new code into existing classes. Note, in the context of method overloading, the signature of a method does not include the return value. But in the context of delegates, the signature does include the return value. In other words, a method must have the same return type as the delegate. This ability to refer to a method as a parameter makes delegates ideal for defining callback methods. For example, a reference to a method that compares two objects could be passed as an argument to a sort algorithm. Because the comparison code is in a separate procedure, the sort algorithm can be written in a more general way. Delegates overview. Delegates have the following properties. Delegates allow methods to be passed as parameters. Delegates can be used to define callback methods. Delegates can be chained together. For example, multiple methods can be called on a single event. Methods do not have to match the delegate type exactly. And C# version 2.0 introduced the concept of anonymous methods, which allow code blocks to be passed as parameters in place of a separately defined method. C# 3.0 introduced lambda expressions as a more concise way of writing inline code blocks. Both anonymous methods and lambda expressions, in certain contexts, are compiled to delegate types. Together, these features are now known as anonymous functions. We'll touch more on lambda expressions in a future video. Using delegates. A delegate is a type that safely encapsulates a method, similar to a function pointer in C or C++. Unlike C function pointers, delegates are object-oriented, type-safe, and secure. The type of delegate is defined by the name of the delegate. A delegate object is normally constructed by providing the name of the method the delegate will wrap, or an anonymous method. Once a delegate is instantiated, a method call made to the delegate will be passed by the delegate to that method. The parameters passed to the delegate by the caller are passed to the method, and the return value, if any, for the method is returned to the caller by the delegate. This is known as invoking the delegate. An instantiated delegate can be invoked as if it were the wrapped method itself. Delegate types are derived from the delegate class in the .NET framework. Delegate types are sealed. They cannot be derived from. And it is not possible to derive custom classes from delegate. Because the instantiated delegate is an object, it can be passed as a parameter or assigned to a property. This allows a method to accept a delegate as a parameter and call the delegate at some later time. This is known as an asynchronous callback and is a common method of notifying a caller when a long process has completed. When a delegate is used in this fashion, the code using the delegate does not need any knowledge of the implementation of the method being used. The functionality is similar to the encapsulation interfaces provide. Another common use of callbacks is defining a custom comparison method and passing that delegate to a sort method. It allows the caller's code to become part of the sort algorithm. When a delegate is constructed to wrap an instance method, the delegate references both the instance and the method. A delegate has no knowledge of the instance type aside from the method it wraps. So a delegate can refer to any type of object as long as there is a method on that object that matches the delegate's signature. When a delegate is constructed to wrap a static method, it only references the method. A delegate can call more than one method when invoked. This is referred to as multicasting. To add an extra method to the delegate's list of methods, the invocation list, simply requires adding two delegates using the additional or additional assignment operators, plus or plus equals. To remove a method from the invocation list, use a decrement or decrement assignment operator, minus or minus equals. Multicast delegates are used extensively in event handling. Event source objects send event invocations to recipient objects that have registered to receive that event. To register for an event, the recipient creates a method designed to handle the event, then creates a delegate for that method, and passes the delegate to the event source. The source calls the delegate when the event occurs. The delegate then calls the event handling method on the recipient, deriving the event data. The delegate type for a given event is defined by the event source. We'll see more about this whenever we cover events in the next video. Right, a ton of extremely good useful information there is, so let's check this out in our code. Open up Unity and create a basic C# script. As always, make sure you give your script a different name than any other class in your project. As always is, for our logouts we will be using Unity Spice. If you'd like to get it yourself, just click on the card on the top of your screen now and follow the instructions on screen. It is completely free, by the way, yes. Okay, yes, let's create a very basic delegate. So let's start with the access modifier, public of course, and then we add in the delegate keyword, delegate. Of course, my spelling has improved. And then we want to put in the return type. And then we want to give our delegate an actual name. So we're going to call this del1. Sure, why not? And then we want to give it whatever parameters we want to pass in. And here we're going to use string. Excellent, yes. So now we can basically treat this like it was, I want to say a type is, but it's kind of more like it's a pointer to a method, I guess. You can call it a handler if you want to. And then you can actually add methods of the same signature as del1 to this actual handler. So let's create another method called void action1. Let's give it string, pass that in, and also then now we want to do our str.log, a simple log. Why not? Well, now if I take action1, set it equal to the handler, you'll see that this is completely allowed. And now you'll see that I can also even call it just like a standard method. Let's add in a, why not? Perfect. Okay, so now let's go back into Unity. Wait for it to decompile and drag our script on any game object in the scene and run our game. You'll see that we get a logged. Now if I take this away, I believe that we get a null reference exception. What if you can actually set that equal to null? You can, but we're of course going to get a null reference exception here, hopefully. Fingers crossed our assumptions are correct. Here it is. I'm pretty sure they are. So as you can see, we're going to try and actually call a method that doesn't have any values associated with it, and you can see we get the null reference object not set to an instance of an object, which is exactly what you would expect here. So let's set this equal to, of course, our action1, and let us do some multicasting. So let's go and do action2. And in action 2, we are going to log this one, but then we're also going to... let's just log out action 2, why not? Nothing too crazy here. Action2.log, and we also want to log out... Actually, let's log out. Doesn't really matter, this is all just part of the demonstration, but well, why not? We'll do it this way too. And allows us to show off Unity Spice too, which is always fun. Excellent. Okay, cool. And now we can go and do handler plus equals action2, as I'm sure you've expected before. Yes, but and you can also, you can also write that like this if you prefer. Yes, equals action2. No, handler plus action2. Handler plus action2. I believe if you write it the other way, it would put action 2 to the start of the list of handler. I'm not actually sure about that, but let's do this first. Let's comment that out. So now back we should get A first, and then we should get action 2-A. Fingers crossed, yes. Hopefully it will all go well. So anyone that's assigned to it, it goes onto the list as you would expect, and sequentially just pops straight through them. Goes A, action 2A. So pretty much what you would expect is, but let's have a little look and see if we can make this go the other way around and add action 2 to the start of the actual invocation list. I believe that this will work. I don't know though. So I'm looking forward to this. Let's see if it works. So as you can see, we did get it, but let's uncollapse it. And you can see, yes, that it does in fact add it to the front of the queue. Even though it happened down here, because we're adding this to the event handler beforehand, it will get added to the start of the list, which is kind of cool. I hope you will agree on that one. I kind of like it. I think it's cool. Okay, so now what else do we want to do? So let's say we created another delegate, and we will give it the return type int, and we will call it del2 because it is a terrible name, and we'll pass it an int I. Excellent. Let's create int action int 1 int I, and let's return let's return just 10. Hey, why not? And then here we will have int 2, and from here we're going to return 20, yes, and then we're going to have int 3, and yes, you guessed it, from here we're going to return 30. Okay, excellent. So let's go and redeclare this one. Del2 handler 2. Naming conventions are still excellent here, yes, as always, as you would expect. But why not? Handler 2 plus equals action int 3. And now I want handler 2 plus equals action int 2. Which do you think is going to be returned is whenever we plug in this? Any ideas? Yep, it's going to be number 20, hopefully, if everything goes correctly. Because the final one that is actually returned is the one that is last on the invocation list. Hopefully that shouldn't be too hard for you to understand this. And there you go, 20 is returned. Simple as that. And these will all execute as you would expect. So let's go through here, 10.log. Come on. Excellent. Oh dear. Come on, Visual Studio. Don't fail me now. Okay, save and head back in. We should get 10, 20, 30, and hopefully 20 will return the final one. 30, 20, of course, and then 20, because the final one to be invoked was action int 2. Excellent. Well, you can actually go through Ace and get you can actually, access the handler itself, and you can actually begin the invoke and have an asynchronous result. I must admit, I've never done that before. Invoke is just a standard, is shorthand for this, which is the standard method. Get invocation list will return all of the delegates individually. So say, for example, you wanted to just do a for each on all of these. You could quite happily do that, Ace, if you wanted to. Action, and then you could actually, oh, maybe you can't. I was under the assumption that you could just go through, maybe dynamic invoke. I was under the impression you could just invoke these, yes, but I guess you can't. For these are just method info. What is this actual thing? A delegate? Okay, so it must be an anonymous delegate. Not really sure on that one, yes, but hey, fair enough. You can by all means go through, get the method info. That's using reflection. I don't really want to get into that too much. You can do a dynamic invoke, and I wonder if you can do a dynamic invoke since it's del2, if I pass in 10 here. Going a wee bit experimental here, is, as you hopefully come to expect from me. Let's have a little look and see what happens if I pass in 10. Well, you see, we're going to just get these out anyway, aren't we? Let's do this like so, and pass in I, 0 and I. Just kind of curious, yes, you know, this is what coding is all about, just trying stuff out. You're like, oh, well, I wonder what would happen if such and such would happen. This is using just the object as the base class. I don't know, this probably will work. Yeah, we're about to find out anyway. Yeah, as you can see, 10, 10, 30, 10, and 20, 10. So it does all work as you would kind of expect it, so long as you're passing in an object. That's kind of cool. Can't think of a reason why you would necessarily want the invocation list. But hey, there it is. If you ever did desire this, which is kind of cool. So, as the doc said, you can, of course, have it so that you remove a delegate once you've, or sorry, a method from the delegate, if you want to call it that. So here we can have action int being assigned, but then we can also remove it. And you can see that we also get the delegate subtraction has unpredictable results. That is 100% correct. Yes, I gotta be honest with you, I really don't like assigning and then unassigning delegates. We'll leave that there maybe for a future video. Maybe now we won't worry too much about it, but let's have a little look at the unassignment process. So we click play and hopefully Unity will restart. Excellent. So it goes 10, 20, 10, 20. No action 3 here at all, which is excellent. I will tell you what, let's even super doubly do it. So you can just sort of see the dynamics of this here is that it actually does all work the way you would expect it to. It will actually call all 3 of them, then it will return that one and log it out. And then as you can see, it will invoke just the 2 because 30 has been unassigned, which is excellent. You can hopefully see the dynamicsness of this is. It is really, really cool. I'll tell you what, oh no, I was going to use a static one, but we haven't actually went over static yet. I kind of want to show you just how cool these delegates can actually be. I tell you what, I will use a static delegate Ace, or at least a static delegate handler. Yeah, that'll do. Okay, let's try it like this is. Yes, let's do it like this. So for this, what I want to do is, because this is going to be static, there's only going to be one of these. These belong to the class Ace. We will go over this in much more detail in a later video. What we're going to do with this is we're going to add an action. How did that one work again? Yes, it was void and there was a string. Okay, excellent. And what I want to do is just to have a very basic action, log action. And we want to have a string s, and we want to log out, oh sorry, s.log. I mean, I probably could have used the other one there is. Which one was it? Yeah, action 1. Ah, well, we'll not worry too much about it. We'll just go log action. Excellent. And see, the problem is I don't want to put them, because then it means, okay. So my plan is to actually have several game objects in our scene just by going to create empty. Oh, of course we have to have Unity not running in order to do this. Okay, so let's go and create empty, and let's call this A1B. See, you can see where we're going with this here is. F2D. Okay, excellent, that'll do. And then we just drag and drop all of these onto our actual game objects in our scene. And what I want to do is log out the actual name of our transform component. Again, yes, we haven't went over any of this stuff, so I'm certainly not expecting us to know it. And we can also use the awake. Sure, why not? Hey, if we're going to go absolutely crazy, we may as well go super crazy. Is transform.name equals this value. So transform.name is going to be whatever our transform name is, which is essentially anything that is here. And then we are going to invoke it. Handler 1, invoke with transform name. That's not going to work. I'm an idiot. I am a complete fool. This is what I wanted to do. Oh, retro, what are you like? What are you like? Okay, Yes. Let's go. Okay, good. This is why I should plan my videos a little better, but then it's harder to do them. That's the reason why it takes so long for me to get stuff out. Anyway, so we're using the awake. Awake's very like start. The only thing is that awake will happen before start Ace. That's the reason why I'm using it here, so that we do our assignments first, and then whenever we call this delegate, it will then invoke all the delegates on the invocation list, and will hopefully log out transform name of all of the game objects that have this script associated with it. Hopefully this is all going to work. We will certainly see this. Hopefully it'll work. Okay, so now whenever I press play, we should get main camera A, B, C, D. Logged out. Fingers crossed. Hey, B, C, D, A, main camera. So as you can see, there's different ways. It's being added in at certain points because of just the way that these are being executed at runtime. But you can see, super powerful Ace. So we can now add this to, maybe say we wanted to add it to directional light. Well, we could just go in and do this. Press play, and now directional light will actually get logged. So hopefully you can see this in action. You can see that this is very, very useful Ace, because you can actually have different classes linking up to different observers, different events, different delegates, and then being called at certain points in your game. And this sort of dynamic link up is what an awful lot of games certainly use. Now this can become very, very tricky, especially whenever you're trying to keep track of all this stuff. And I had to add in, by the way, the if statement here is so that it only called once, because if I take away this, of course, then it's going to run several times. It'll be interesting to see. I expect it to come back with 6. No, yeah, I expect it to come back with 6. So hopefully if I collapse this, we will see 6 beside all of these, because it's going to invoke the entire invocation list 6 times for each of the 6. Hopefully that makes sense, yes. Whereas if I have in the if statement, then it's only going to do it once, and it's only going to be called once whenever the main camera, of course, is true. Hopefully that all makes sense, yes. Hopefully you can see the power of the delegates in action. We are going to look at events. I gotta be honest with you, I'm not the biggest fan of events, but we can certainly have a look at them and see them in action. And certainly I think that's enough for now. So yeah, rate, comment, and subscribe. Yes, I hope you're enjoying this series. Sorry for the hiatus. Life got in the way, and really that's the only thing I can say about that. You can email me at retrotk2@gmail.com if you have any questions about what we have discussed today. Thank you for watching this, and I'll see you in the next video.